So this is the exploring types of reaction lab. So we can check the temperature. So here the temperature is almost 22, 21.9. Okay. And then we add a catalyst. A catalyst is something that helps the reaction happen faster. So right now, my hydrogen peroxide is getting weaker and weaker, but very, very slowly. The catalyst will make this happen more quickly. And let's see, steam. And we're going to watch. And we can see the temperature is climbing. And so clearly the temperature goes up. Let's mix this up a little bit. Nice. So one of the tests is to see if you can get a popping sound, and you don't. But if you put a match in there and it relights, that means that you have oxygen being produced. And so we changed the hydrogen peroxide into water, you saw the steam, and oxygen, which is characteristic, like it's helping my fire relight inside there because I have oxygen available. Nice. Experiment number 1, done. Experiment number 2 is a solution of copper chloride. So a solution means that you have a mixture of different things. So here I'm in the background adding some copper chloride to the test tube. And that's what copper chloride looks like when it's not in solution. And then if I add some water to it, it becomes a solution. So let's mix that together. And it's unfortunate. So in the solution process, it got warmer, but I didn't create anything new. I still have copper chloride in there, and that copper chloride is in there. I need a little more water so my temperature probe can reach it. So let's add some. And this is just like the water that comes from the tap that has air bubbles in it. We're getting some mixing going on that's causing air bubbles to be formed, not really making any new substance. I don't think, unless there was something in there. Nope. Okay, so there it is. And I know that got a little warmer, so let's look at the temperature. And you can see more little bubbles forming. We'll just like, it must have had a contaminated container. So about 36. Okay, 36 and a half. All right, so now we're going to add some aluminum. So I'm going to take a piece of aluminum foil that I can put inside. And we're going to react an element. This is just aluminum with a compound, copper and chloride. Let's push that down. And you can see the reaction. Let's bring it a little closer. Then focus, there's a darkening. And if there's just a little more light, you'd see it's a little reddish. Right there, maybe you can see it's a little reddish. New bubbles. Yep, it looks like new bubbles forming. And we're going to come back to this later, but let's see if that helped the temperature. Remember, it was 36.5. And well, that's interesting. Oh. There we go. Reconnected, and it went up to 63. That's a pretty big increase in temperature. We'll come back and look at some more of that, but since you're writing stuff down, looks like the original blue color is gone, or quite a bit of it's gone. And there at the bottom is like a brownish red color that's happening. So we'll come back and we'll look at each of these. Okay, the next one is to start with some copper chloride. So I already have some made up. Again, we need enough so the temperature probe can reach it, so we know where we are the beginning temperature. Cool. Okay, clearly it's going to go down. Cool. Okay, 23.8. And then we're going to add sodium hydroxide, which is a base. Add some that. And we can see a slight change in color. I think we can get a little more reaction out of that. Slight change in color. Looks like the temperature basically stayed the same. And you get this, I don't know, like a jelly sort of look. You can't see through it, right? But doesn't feel like a solid in there. But if you can't see through it, that means there's something solid that's sort of floating in there. So that solid is the solid in your paper, CuOH2. So we've made this CuOH2, and you can see the color changed from that nice bright blue to a little bit of greenish color that's happening. Maybe some white. Okay, and then the last reaction is to add HCl to the solution and try and get this to go back. So one of the reasons I wanted to do this part was to show you that just because you make a product doesn't mean that you have to not be able to get it back again. So we should be able to get back our product. So I'm going to check the temperature one more time. Because all our observations are about change. So, well, what did we start with? What did we end with? And what we're trying to figure out is what is the change that's occurring during the reaction. Actually, it looks like the temperature went, maybe not. I'm not sure I'd say the temperature went down. Looks like it's pretty much the same. All right, let's add the acid. And there we go. See if we got a temperature change out of that. Remember, it was about 23.6. I think that's enough to say it went up a little bit. Yeah, definitely. Almost a whole degree. Not as drastic as the previous ones, but we went up a whole degree during that change. Okay, let's look back at what we did. We created something a little more brown. I'm going to get away from the temperature thing so maybe we could see a little better. Something brown at the bottom, which happens to be the change that happened to the catalyst. The liquid itself now has less hydrogen peroxide in it, which means that a catalyst can no longer, let's get this back up, a catalyst can no longer cause change. And the reason the catalyst can't cause change is because the reaction's all over. I don't really have any hydrogen peroxide left. Here I clearly went from this light blue of my copper chloride to a greenish color, and at the bottom I have it looks like moss, and it's sort of flaky and brown to brown red color, which I'm sure is hard to see in the video, the exact color. So we got that, and let's see if that would still react. So here's a little bit of aluminum, and we'll push that down. And you can see, let's bring that into view. You can see I still must have a little copper chloride in there because look, I got some more brown happening around the edges, and so some more reaction. Now the bubbles do not represent boiling. It's not getting that hot. The bubbles represent a secondary reaction that's happening to create bubbles. And then finally, our two solutions. This is the copper chloride that I made with the acid where the temperature went up. And in reaction 3, we added the base. Just going to add some more base back in there. And look, we can see both of the reactions together. Maybe a little bit of mixing. But we had like this light blue to clear solution when we added base, and then when we added the acid, it went back to this color. So overall, a really good result. Those are our 3 reactions. You have to write about what you observe. Remember, observations are not what you made. Observations are about what actually happened. And it says changes in color, temperature, and odor. Think about the state of the products. And one more time, this is the 2 solutions. The base is on top, the acid's on bottom. And there's that color, a lot more clear what that color is that's being made. And diminishment of the color from the blue to a very, very pale green now. And then the final one was just a clear liquid solution, and I'm showing that the catalyst no longer is effective at changing it.